Now let's put everything together and look at writing rational functions from intercepts and asymptotes. So example 8 says, write an equation for the rational function graphed here. So what we want to do is we want to start with things that we know. First thing that I know is that I have x-intercepts at, let's see, we have one at x equal to -2, and we have one at 3. So I'm going to take those two x-intercepts and go ahead and put them into factors. So that would be x plus 2 and x minus 3. Then I'm going to look at my y-intercepts. So I have a y-intercept and we have it right here. And this is at the ordered pair 0, -2. So if I use that, we're going to use that as a xy value here in a minute. We've got x-intercepts, y-intercepts. Now look at those asymptotes like we saw in the previous video. So I have a vertical asymptote at, let's see, we have one here at x equal to -1, and we have one here at x equal to 2. So at x equals -1 and 2. And then our horizontal asymptote, we can see that we have one created here along that line y equal to 0. So let's put all this into play. So if you remember from the location of the information on how that helped us define intercepts, we're going to have f of x is equal to a, how the possible width has been stretched or shrinked, etc. We know that our x-intercepts exist on the top half, and so that would be x plus 2, x minus 3 going up here. And then we know that we get our vertical asymptotes when our denominator gives us a 0. So we know we're going to have our x plus 1 and our x minus 2. And this is going back to these vertical asymptotes here in the denominator. And we can see that right here at 2, since these are going the same direction, then we're actually just going to have a squared right here. So just from our x-intercepts and our vertical asymptotes, we can figure out the rational function's numerator and the rational function's denominator. Now we have to add in more information in order for us to find the a value. And so what we're going to do for that a value is we are going to now look for and use the x-intercept. Using the x-intercept gives me an x and a y value that exist within this function. So I'm going to plug those in here for y and then for all of these x's right here. And so that's going to give me -2 equal to a, which I'm trying to find, 0 plus 2, 0 minus 3, all over 0 plus 1, 0 minus 2 squared. I'm going to simplify and solve. So that gives me a, let's see, I have a 2 and a -3 on top, a 1 and a -2 squared on bottom. Let's do some arithmetic. So that gives me -2 equal to -6a over -2 squared is 4. And then I'm just going to solve for that a. So I'm going to go ahead and multiply both sides by 4. Gives me -8 equal to -6a and divide by -6. So that would be reducing 4 over 3 as our a. And so now if I go back to my problem up here, this means f of x is equal to, I'm not going to put 4/3 in the top of the numerator. I'm going to go ahead and set up my 4/3 as a large fraction. In the top, I'm going to put those x-intercepts. And in the bottom, I'm going to put those vertical asymptotes. And so you can see just from knowing where we can identify our asymptotes, where we can identify our intercepts, etc., we get the information we need in order to set up an equation. Let's do one more example before we end this section. This one is dealing with our slant asymptotes. And so this is from case 2 from the previous video of the degree of the denominator being less than the degree of the numerator. And so let's see what's going on with this one. If I take this function of 3x squared plus 2 over x minus 5, and I've given us a graph over here to the right, and we'll come to that in a minute. When you have a rational function set up, this is a division problem. So if I go back to my long division, I'm going to say 3x squared plus 2, and I divide that by x minus 5. Following my rules of long division, I'm going to compare my x to 3x squared and say x times what would give me 3x squared. And that would be a 3x, and I'm going to multiply. 3x times x gives me 3x squared. 3x times -5 is -15x. And then I'm going to subtract the whole thing, which typically I just change all the signs. So this cancels, and I'm left with 15x plus 2. I can't put those together because one has an x and one doesn't. Then I'm back to comparing. X times what would give me 15x, and that would be a positive 15. And I'm going to say 15 times x would give me 15x. You always want that number to be the same. 15 times -5 gives me -75. And again, I'm going to subtract that whole thing. So I'm going to change all the signs, and then I can combine. So that gives me 77. And so what this does for me is when I divide this out, this answer right here that I achieve is where my slant asymptote is going to be created. And you can see that here from this dotted line. You see how it's crossing here at positive 15. It's going up 3 and over 1. You can see it has a positive slope. So that case 3 of the degree of the denominator being less than the degree of the numerator, we can actually physically divide this out using my long division in this case, and this will create where my slant asymptote will be in regards to this question.